So last time we started with this topic, which is about level of service and capacity, and I told you we will do it for uninterrupted flow facilities only, and this is the outcome we are focusing on, which is directly related to level of service and capacity. Definition of uninterrupted flow facilities, we already know that. We just saw the limit of 2 miles here. Then the manual which we follow for this process, the definitions of capacity which is given by the manual, so it is more detailed, and it mentions what are the things which can change the capacity, ideal values of capacity, why do we need the concept of level of service, the definition of level of service, and the levels of service. Okay, so how many we have? 5, because they are 5, right? We have 6, right? We have the 6th one, which I will give it to you, no problem. Huh? No F? Anyways. Okay, so today I'm going to start with this thing. So the level of service goes from A to F, right? Just like your grades. Huh? Sorry? No? No E. I thought no A.
A, B, C, D, F.
Okay. But for example, if I say he got an A, okay, so I must have calculated that A using some number, right? Must have a number, and that number will tell me he should get an A, he should get an F, something like this, right? Okay, so that number is called as service measure. Okay, so service measure is a traffic parameter which tells you how much should be the level of service. Okay, so we don't just assign it, or in many cases we don't just assign it. We have to calculate something, and that thing will give us a level of service, and that thing is called as a service measure. Okay, what we will study now, uninterrupted flow facilities, right? So for most of the uninterrupted flow facilities, we use density as our service measure. So somebody asks me for a level of service for multi-lane highways or freeways, I will do it using density. Okay, to calculate level of service, I need density. Got it? Okay. Then there are some other facilities mentioned here. For example, interrupted flow facilities. Interrupted flow facilities have what? What is the difference between uninterrupted and interrupted? The intersection. So interrupted means now we are dealing with the intersection. For the cases of intersection, the service measure is delay. To calculate the level of service for an interrupted flow facilities, meaning an intersection, I need the delay value. So you calculate the delay value, you can get to the level of service. Got it? Okay. Then there are some facilities which are related to other road users, not drivers and passengers. For example, bus service, pedestrian crossing, and these things. Okay. So for these things, they take the perception. Where is it? Okay. For pedestrian facilities, they do the perception index. You can read about them as well for your senior project. Okay. So they are the So the highway capacity manual already has a index, but that index is based upon opinion of the pedestrians. Okay, and that is only used for pedestrian and bicycle facilities. They are crossing. If you have a bicycle lane, then you can use that. Clear? Then we have the 2-lane highways, which are slightly different from the other, and it uses 3 service measures. To calculate the level of service for a 2-lane highway, I don't need 1 value. I need 3-4 values. Okay, or 2 or 3 values. Okay, we will discuss them in the next topic with detailed calculations. Okay, but the main thing is, if it is uninterrupted, we mostly need density. If it is interrupted, we mostly need delay. If it is pedestrian or bicycle related, then we calculate it using their perception, their opinion. Got it? Okay. And then 2-lane highway we will discuss later on. level of service changes according to traffic on the road. Agreed? Okay, so it goes from A to F. Traffic increases, where will the level of service go? If it is B, let's say. If traffic increases, will it go to A or C? C, right? Okay, this makes sense. Now, but traffic is a number, right? Traffic is a number, and level of service is a letter. Okay, so I need a value at which I will change the letter. Going back to the example of the grade. Okay, so at what point you go from A to A minor?
3.67.
No, the number, the grade. Below 90? Okay, so this is a number, right? There's a limit. Okay, up to this limit, it's all, or more than this limit, it's all A, right? When you reach to this limit, anything below that is A minor. Got it? Okay, so this limit for level of service is called as service flow rate. Okay, so service flow rate is the limit of traffic at which the level of service changes. Okay, so at every level of service I have a range of flow rate. If you are within this range, your level of service will not change. When you get to the edge, it will change. Okay, so for example, let's say the service flow rate for A is 1000. So 0 to 1000, your level of service will not change. It will remain what? A. Now you cross 1000, it will start changing. Got it? Clear? So that limit of 1000 is what we call a service flow rate. Okay? Clear or not, everybody? Okay. So every level of service has a limiting flow rate value. When you reach to that value, that level of service will be gone. Clear? Okay. So we have a limiting value for A and B and C and D up to when you reach E. Okay. The service flow rate, the limit at E is basically the capacity of the road. Okay. Clear? The limit at level of service E is the capacity of the road. Now, what about the service flow rate for F?
Any number higher than E is the capacity. The capacity.
Capacity is where E ends. Service flow rate means what? Where the level of service will end, right? So what about F? Anything over capacity, right? Does it end? No. F doesn't end. All other grades end. F does not end. Got it? Okay. We don't have the royal family here. Otherwise they will tell you. F doesn't end. You take the course 4 times up. Doesn't end. Okay. Or maybe some of you will come next time as well. You will tell me. F doesn't end. Okay. In these slides, we will talk about 2 types of uninterrupted flow facilities, freeways and multi-lane highways. Okay, so we need to define them. Okay, freeways are those highways which are pure uninterrupted. They actually do not have any intersections. Okay, the highways which do not have any intersections. In Bahrain, they call them motorways. Okay, the UK terminology is motorways. So a highway which has no intersections, basically. Another feature of a freeway is it has a median. It always has a median. You will not find undivided freeway. Okay, freeways always have more than 1 lane in each direction. So total is always more than 2 for freeways. Got it? So what are the 3 things I told you about freeways? Median. There's always a median, and more than 1 lane in each direction, and no intersection. Clear? Okay. So intersection means they don't have any at-grade intersection. There is another thing which we call as interchanges. So they are there. The ramps, the bridges and tunnels, they are there. Okay. So they will not make it. They will not disturb the interruption. the interrupted flow, they will not make it interrupted. Okay, it will remain uninterrupted. Okay, so freeways, because they have so many parameters fixed, only thing which changes, okay, or which makes the most of the changes in the design is number of lanes. Okay, so when you say freeway, you will tell me how many lanes you have. Okay, then we have multi-lane highways. They are not purely uninterrupted, they have intersections. So there are parts of multi-lane highways which are uninterrupted. Which parts? Which part of the multi-lane highway will be uninterrupted?
Distance more than 2 miles.
Yes. If you have two intersections on a multi-lane highway and the distance between the two intersections is more than 2 miles, then that part becomes uninterrupted. Okay. Multi-lane highways means number of lanes are more than 2, total more than 2. Okay, because if this 2 lane, then we call it 2 lane. Okay, and they may or may not have a median. Okay, so what are the differences between freeways and multi-lane highways? Median and it's not purely interrupted. We are looking for the distance. Okay, distance more than 2 miles, we say it is uninterrupted. Okay, in that distance, when the intersection comes, it becomes interrupted at that point. So the whole highway is not uninterrupted. Clear? Okay, and what is the similarity between freeway and multi-lane highway? What is the similarity between them? What is common? Multi-lane. Both of them are multi-lanes. Okay. Why we are discussing them together? Because their procedure is same. Both of them need the same parameters, and in most of the cases they are using the same equations and the graphs. Okay. In both cases, you start your calculation with the free flow speed. Okay. Free flow speed is a speed when the traffic flow is almost none, right? Okay. So the first thing which you need for both of them is the free flow speed. Okay, you will need it for others as well, but the rest of the procedure is also same for them. Okay, so now they have defined, and actually we have seen this limit somewhere else as well. Where? They are saying free flow speed is a speed when your flow is less than 1000 vehicles per hour per lane. Where did we see this limit? Spot speed. Okay, easy, right? Only thing which we did, the only chapter we did on speed. So spot speed, same, because spot speed is done for finding out the free flow speed. Okay, clear? Yeah, for both of them, for multi-lane highways and freeways, we are doing the calculations according to a speed flow curve. Okay, I showed you the curves, right? The ideal curves earlier. I'll show you another one which is more practical and which is given in the manual. But this curve, the same curve is used for multi-lane highways and freeways. There are some base conditions, meaning ideal conditions. Okay, when you start the analysis, you need to keep these conditions in your mind. Anything which is not ideal, you will make an adjustment for it. Got it? Okay, if that means the ideal condition, no adjustment is required. Clear? So we will make many adjustments later on. You will see them. Okay, but we are starting with this. The first one is no heavy vehicles in the traffic. Okay, so no heavy vehicles means all of them are what? Passenger cars, because passenger cars are light. You can pick them, right? Don't try. And all drivers are familiar with the highways. Okay, these two are ideal conditions for traffic flow. There are other ideal conditions as well, we will discuss. Okay, but these two are ideal for traffic flow. Okay, because passenger cars have the optimum level of acceleration. Heavier vehicles, okay, their acceleration obviously is lower. Okay, and bikes, maybe the acceleration could be higher because of their weight, but the speed, they cannot reach the speed of a good car. Got it? And familiar drivers. So if drivers are familiar, their lane changes are less, their speed is usually higher, they go with less spacing, and so on and so forth, and they become very confident, right? So confident they feel they can do anything, right? So these are two base conditions for traffic flow. This is description for each level of service. Okay, you can read the points later on. I will tell you the most important things here. First of all, level of service A means free flow. Okay, when we go from A to E, the most important element which you will see changing is average spacing. This is the highest average spacing, and as you go down, the spacing will get less. Okay, and this is again for multi-lane highways and freeways. This is for multi-lane highways and freeways. Got it? Okay. So free flow means you are choosing your speed. So drivers are so far, the other cars are so far from you, your speed does not have any impact. Okay, and you have why you are so confident about your speed? Because you see a lot of space around you which is empty. Okay, so the other lanes are empty, you have a lot of distance in front of you, and so on and so forth. Clear? So that means what? If, for example, somebody has an accident in front of me, only one car, okay, or a car has a problem, it's stopped, I can easily go to the other lane and continue in this condition. Clear? Level of service B is still free flow, but the spacing is little bit less. Okay, so you are still going at high speed, but your level of caution is increased. Okay, now you start to feel the presence of other drivers. Now you start to feel that I should be more careful. We are just feeling it, not doing anything. Got it? Okay, we are just feeling it. Yeah, they are drivers. Got it? So the spacing is decreased, and why we have this? So we see the spacing. The feeling of care is because of the spacing, but the spaces are still enough. I have still enough gaps in my lane and the other lanes that I feel confident. If something happens, I can easily go to the other lane and continue. Okay, so this is why we are still going at free flow. Level of service C is still free flow, but your maneuverability is less now. It's restricted by other drivers. So if I am going in my lane, I can go at very high speed, no problem. But if I decide to change my lane, then I may have to wait for a gap. Okay, so if I still have a gap, okay, but the frequency of the gaps is less now. Got it? Okay, there is still gap, but if it's not like whenever I want to change my lane or slow down, I will find a gap. Okay, so and you can see the speed is going down, and since the frequency of the gaps is less, if somebody stops in my lane, it may cause a traffic disruption because I don't have the chance to go in the other lane. Or maybe I will have the chance, but the driver behind me will not get the chance. So what they will do, they will stop. Okay. So from level of service C, you have the risk of disruption. Okay. In the other two levels, the disruption risk was very, very low because of the frequency of the gaps. Got it? Clear? Yes.
What's the number of cars? 15 cars and
This is spacing converted to car lengths. So 203 feet basically equals to 10 car lengths. Almost. Okay, each car is around 18-20 feet. Okay. You may say, no, my car is bigger. Good for you. Okay, not according to them. So this is spacing converted to car lengths. Then we have level of service D. This is where the free flow condition goes out. Okay, so there is no free flow now. There's free flow. No free flow means the speed is reducing now. Okay, the speed is becoming less. So that's again why, because of the spacing. Okay, so the main factor here in all of these is the spacing. Okay, you are facing all these phenomena because of the spacing. So spacing is much less now, so you don't feel confident in going at the highest speed. So you start to reduce the speed, and reducing the speed means and the density. Sorry, spacing is also related to density, right? It's an inverse relationship. So when spacing increases, density. When spacing decreases, density increases. Okay, and that has an impact on speed as well. Now, because the spacing is less, the gaps are less, and their frequency is also less. So the chance of disruption is even higher now. Okay. In the earlier case, there was a chance. I want to change my lane, I may find the gap easily. But in this case, you will not find it. Okay. So even a minor disruption can cause a full traffic jam. Okay, because now there are not too many gaps available. So if there's a stoppage, the drivers will form a queue because all of them cannot move to the other lane at the same time. Got it? Okay, so the chance of disruptions are higher even with a minor blockage. Okay, so maybe the other car did not even stop completely. It just slowed down. It has a tire burst or whatever. So it just slowed down and it's going to the shoulder. Even that can cause a queue. Got it? And then we have level of service E. Level of service E represents what? Which condition? Capacity. Okay. Capacity means full saturation, right? Full saturation. So where are the gaps now? No gaps. Does it make sense? Yes. For you guys, yes. Traffic flow without any gaps. Does it make sense? Now you're just saying it because I said it. Huh? You don't mind, huh? Without gaps, no problem. Who needs the gaps? Let me go over this car. There are no usable gaps. There is gap, obviously. There is a gap. Okay, between two cars there will always be a gap. So there are no usable gaps, meaning gaps which you can use for your maneuvers, gaps which you can use to go into the other lane or slow down or go to the shoulder and so on and so forth. Okay, so there are no gaps like this. In a moving traffic stream, this gap is not enough to make these maneuvers. Okay, if I park my car, if there are two cars parked behind one another, this is too much gap. How many cars? 6 cars. Okay, so if it's in a parking area and if there are cars one behind one another, the gap will be much lower. Even on a signal. On a signal, when you stop on a signal, you don't stop at a spacing of 100 feet. Okay, your spacing is much less, maybe 1 or 2 meters. Okay, but now we are talking about moving cars, not stopped cars. Okay, so that's why I'm saying there are no usable gaps. No usable gaps means you don't have chance to go into other lanes. Okay, so even if there is no disruption, just a driver who is going in his lane, now he has to take a right turn, so he wants to go in the other lane. Even this will cause a disruption here. So normal routine traffic operations will also cause disruptions in this case. Okay, this is a speed flow curve I was talking about. Okay, so we have speed on the y-axis, flow rate on the x-axis, speed in miles per hour, and flow rate in, what is this? What are the units here? Passenger cars per hour. Clear? Okay. We have seen this part of the curve earlier in lecture 1 as well. Okay. Free flow speed maintains up to a high flow level. Okay, the thing which we see with modern drivers, you guys. Okay, so you start to feel the presence of other drivers, but you still think that I'm in Formula 1. Okay, so you continue at your speed. Okay, until you reach this point where you start to, where the flow increases to a level where the speed actually starts to go down. What was that level of service? When the speed starts to go down, which level of service? D. Okay. So from here to here, you are almost in level of service C. Not for all highways, but it's almost level of service C. Okay. So this is D and E. This is D and E. Okay. So start to go down. This is D, and you reach this one capacity, which is level of service E. Clear? The point at which you see the shift, that point is called break point. Where the shift of speed happens, that point is called the break point. Clear? Clear? Okay. Now tell me, for the first part, before the break point, what is my speed? free flow speed. Okay, it is fixed, it is constant, there is no equation required for that. After that I have a curve, right? I have a curve. So this is the equation of the curve. This is the equation of the curve. Okay, so this equation is only for this little part. Clear? You want to do more whistling? Come on. So this is, now I will come back to this part, adjust it later on, okay, in the coming slides. But this is free flow speed, right? This is free flow speed. This is capacity of the highway. C is the capacity of the highway, which you will find at this point, the x value at this point. Clear? Okay, we will see the equation to calculate capacity. But if you come to the graph, this is capacity. Got it? Then what do we have? Density at capacity. Okay, DC means the density at this point. The density at this point. And how am I getting the density? Slope. Okay, density is flow upon speed, so that's why. Density is flow upon speed. So if you make a line and find out the slope, it can be density. Okay. For according to highway capacity manual, for freeways and Multilane highways, they are saying the density at capacity is 45. Okay, so although you see in the equation DC, but that DC according to highway capacity manual and their standards for freeways and Multilane highways, this is 45. Clear? Okay. What else? Now this equation will give you S, right? What is S? Y. Okay, so Y should be calculated according to X, right? Got it? So my X is Vp. Okay, the flow rate. Vp is the flow rate. Okay, Vp is my flow rate. And where is my flow rate? On the x-axis. Clear or not? Okay. Then what is BP? What was this point, break point? L7C. But what happens at this point? The speed begins to decrease. Okay, the break point. Okay. Then we have the coefficient, which is A. Okay, so you have all the parameters. A is the coefficient. I will show you how we get it. Okay. For free flow speed, we already know how to get it. Free flow speed, we already know how to get it. How do we get the free flow speed? Okay. Okay. From equation. There was an equation. There was an equation. Okay, fine. Spot speed study. Okay, both of you are correct. But here we will see another equation for free flow speed. Okay, that was a very simple equation. So those equations are used for understanding the traffic relationships. Okay, so but in highway capacity manual, they are more practical equations. So you will see more parameters here. Okay, but this part we already covered. Okay, then we come to capacity. Okay, capacity can be calculated using this equation if it's a freeway, and using this equation if it's a Multilane highway. Okay, in both the equations I need one thing only, which is free flow. Clear? If you know the free flow speed from the first step, you can calculate capacity for any types of highway, both these types of highway. Got it? Then we have the break point. For freeways, this is the break point. Again, what do I need? Free flow speed. Okay, I will talk about this factor later on. Okay, I need another factor here. For Multilane highways, it's a value. There is no equation. Okay, the break point has a value for Multilane highways. Okay, and then you saw in the equation there was a parameter A. Okay, so A they have already found using some field studies. So there is no equation for A. If it is freeway, it's 2. If it is Multilane highway, 1.41. Clear? Clear? Okay. So the only thing remaining here are these factors, SAF and CAF. I will come back to them. Okay. But you know the parameters now. Free flow speed, capacity, break point, and the A value. okay, which we required for the previous equation. These are speed flow curves for freeways, for specific freeways. Okay, you will make one of these curves for your term project for your highway. So your curve should look like this, with one line, obviously, one curve and not one line, one curve. Okay, don't get overexcited. I'll make 5 curves. You cannot. It's one highway. Okay, these 5 or 6 are for 5 or 6 highways. Okay, you have one highway, so you will have one curve. Okay, and then you see the lines, right? You see the lines in them. Each line is representing what? No, each line, not the curve. Level of service, right? Density or the level of service. So you will have all these lines. You will have all these lines. Clear? Clear? I'm just going to explain the curve. How to make the curve, I will explain it in another example. Now I'm just going to explain the curve. Okay? Clear? So we already know on the y-axis speed, on the x-axis flow rate. Okay? Each curve represents a different free flow speed, means it is for a different highway. Okay? Clear? Each line represents a level of service, or the region of the level of service, the range of the level of service, and that range depends upon density. Okay? And why I am putting density on these lines? Because density is what? Slope. Okay, so density is the slope. Now from where am I getting these values? 11 and 18 and so on. These are the ranges of density given in highway capacity manual for level of service, these levels of service. So level of service A has a range of density from 0 to 11. Okay, level of service B has a range of density more than 11 to 18 and so on and so forth. Got it? So for example, you observe the speed and flow rate on your highway and you have these curves. So you come and you plot your point. Okay, so let's say my free flow speed is 55, because this is how high I can go, 55. Okay, and let's say my flow rate is 1000. Okay, so speed 55, flow rate 1000. Clear? So what is my level of service? Clear? This is how you can use this graph. Can you use this graph for your highway instead of finding out the level of service by doing the calculations which we later discuss? Can you just plot the points and take the level of service from here? Can we? We can and we may not. Okay, it depends upon what? Free flow speed. Okay, depends upon the free flow speed. There is no interpolation here. Okay, there is no interpolation. Don't try to be ChatGPT. Okay, I can see the graph. This between this and this, it must be 40. No, you cannot do this. Okay, it's a graph. They plotted it. They are showing it. This is it. Okay, if you have a point somewhere between the two curves, I don't know where is it. Got it? Clear? The same graph for multi and hybrids, but again you can see the free flow speeds. One thing for capacity, you can see the range for freeways for the free flow speed. Okay, and then the range for multi and hybrids for the free flow speed. Okay, a highway which has more than 45, most probably it will not be. A highway which is more than 70. Most probably it will not be multi-highway. It will be a freeway. Okay, because that high speed cannot be with intersections. Okay, and a highway which is less than 45, again most probably it will not be uninterrupted. Okay, and same thing here. Highway which is less than 55, most probably it will not be a freeway. Okay. Another thing which you can see here, they have also given limits for the capacity value as well. So the equation will give you a value and you will check it with the limit given here. So the equation gives you are doing it for a freeway, and the equation gives you 2500. Freeway 2500. What is the limit? 2400. Okay, so I have the limit and I have my value. Which one would I take? The limit or the value? Huh? The value is higher, the limit is lower. What do you take? Huh? The limit. Okay, you cannot exceed the limit. Okay, so if you have a value which goes beyond the limit, limit is your value. Okay, but the equation gives you 2310. The limit is 2400. You will take the value. Got it? Clear? So the equation cannot be used, these equations cannot be used outside these ranges. Okay, when you hit the range, this is the final value. Clear? Okay, these are the ranges of density I was talking about. Okay, for each level of service, the range of density is given. Clear? Okay, just have to be careful with the equal to. So A goes from 0 to 11. But if it is 11, it cannot be B. B is more than 11. Got it? Okay. In highway capacity manual 2010, and this is what they are using it in the ministry and the other companies as well. They converted the density using the flow rate and the capacity into V by C ratio, volume upon capacity ratio. Okay. So now you have two methods to find out the level of service. One is using the density range from highway capacity manual, and the other one is using the V by C ratio. Okay, this is more practical. This is what they use, because capacity of the highway they already know from their design, and volume they can go and observe. So volume upon capacity ratio is very easy. Got it? Clear or not? Any questions? Okay. Yeah. I talked about service flow rates earlier. What is service flow rate? What was service flow rate? Limit for? To change between the level of service. Okay, now I go back to this graph. Okay, let's say your free flow speed is 45. Okay, so I'm looking at this curve. And these are the lines I have plotted for level of service. Okay, now if I ask you what is the service flow rate for level of service A from this graph for free flow speed of 45, how will you find it? I need service flow rate for level of service A from this graph when the free flow speed is 45, and I have these graphs now. So how do I use the graph to find out service flow rate for A, level of service A?
We see the intersection between the curve and the slope.
Yes. So you have the line for level of service A, and you have the curve here. Where is the flow rate? On the x-axis. Okay. So I go here. Let's say this is 650. Let's say. Okay. So if I'm below 650, I'm on this side, right? So my level of service is A. If I'm more than 650, then I'm ahead of this line, right? So my level of service will change. Okay. So wherever you have the intersection points, you can go to the x-axis and find out the level of service. Oh, sorry, find out the service flow rate. Okay. So service flow rate is the intersection point between the level of service line and the curve. Got it? Clear? Okay. For these curves, they already did this, the intersection point, and these are given in these tables. Okay. So from where did I get these values? 820, 1310, and so on and so forth. My free flow speed is 75. 75. I have these lines. Okay. So where is 820? Level of service A, right? Free flow speed 75. Free flow speed 75. Level of service A. I go there. This intersection point is 820. Okay. Then 1310. 75, level of service B. I go there. This intersection point is what? My service flow rate for B. Clear? Any questions? As I said, I will discuss later on how to plot these curves. Okay. Same thing for multi and highway curves. So this one was for freeway curves, and this one is for multi and highway curves, these curves. But the concept remains the same. You have the curve and you have the intersection point for the level of surface line. Okay? Okay. I skipped over one thing, which is the adjustments. In the equation, we were not using free flow speed plain. We were using free flow speed adjusted. The adjustment means I need to multiply with something. I will take my free flow speed, whatever I have, okay, the raw value. I multiply with the adjustment factor, it will become adjusted free flow speed. Same thing for the capacity. I'll calculate capacity from here, and then I will multiply with the adjustment factor of capacity. And that adjusted value will be used in this equation. You can see in the equation, adjusted capacity, adjusted free flow. Got it? So from where do I get the adjustment factors? The adjustment factors for speed and capacity are because of 4 conditions. Adjustment factors for speed and capacity are because of 4 conditions. Okay, and they are listed here. Weather, driver population, incident and work zone. Okay, weather condition, driver population, incident and work zone. Okay, weather we know, rain, snow and other things we don't have in value. Okay, and the only thing we have the different types of weather conditions. Okay, driver population I already mentioned. What was the ideal condition for drivers? All drivers are what? Familiar with the route. Okay, if they are not familiar, then we have to apply the adjustment factor. Got it? Clear? Incident. Incident could be an accident, it could be a check post, okay, it could be something, okay, something which will disturb the flow, something which will disturb the flow. It is not a permanent interruption, but it will disturb the flow. Got it? It's considered as an incident, okay. And then we have the work zone. Work zone means if there is construction or maintenance work going on, okay. This construction maintenance work can be on the road or it can be beside the road. Okay, sometimes it is beside the road, but it is affecting the traffic, so we have to consider it. Okay, so there are 4 adjustments: one for weather, one for driver population if they are not familiar, one if there is an incident, and the last one if there is a work zone. Okay, so the last 2 you know if you have it or you don't have it, right? You have a work zone, you don't have a work zone. You have incident, you don't have incident, right? Driver population, weather, they have different conditions. Okay, now this table gives you a summary of what adjustment factors will apply where. Okay, so you can see all 4 adjustment factors apply to capacity. Okay, all 4 conditions apply to capacity. So if any of these conditions is not met, an adjustment factor will be applied to capacity. But for the speed, only 3 apply. You can see a no here. Okay, which one is that? Incident. So if there is an incident on the road and all the other conditions are met, I will not apply any adjustment factor to speed. Got it? Clear? So if there is an incident on the road, it does not need any adjustment factor for the speed. Got it? Okay, now from where do I get the adjustment factors? I'll come back to it. Okay, this is the table which gives you adjustment factor for weather on capacity. Adjustment factor for weather on capacity. So what type of weather you have? How do I know I have this type of weather? So there is a value, right? Okay, so you cannot call anything as heavy rain. No, there is a value. Okay, so we have the weather, we have the value to define it, and then we have the adjustment factor, and we need the free flow speed as well. So this table gives you adjustment factor for capacity for because of weather, and this table gives you adjustment factor for speed because of weather. Same things. You need the same things. You need the weather condition and you need the free flow speed. Okay? Clear? This table gives you adjustment factor for capacity because of incidents. So if there is an incident, then what do we have to see? Obviously, if there is no incident, the factor is 1. Okay, no incidents, ideal, right? If there is incident, then you have to see how many lanes are closed because of the incident. So it's disturbing the traffic flow, right? So it's disturbing the flow in how many lanes and shoulders. Got it? So if there is an incident and only shoulder is closed, you will take the factor from here. If there is an incident and one lane is closed, you will take the factor from here, and so on and so forth. Clear? Okay, who will tell me the meaning of this?
There is no more lane.
There's
No more lane.
there is no more lanes. Okay, so 2 lanes, if 2 are closed, happy times, right? We can like put food trucks there, we can have picnic there. No need to get into these calculations and destroy our life. Okay, have fun. You will do it on 16, right? 16 December, right? Okay, this is the adjustment factor for capacity and speed for because of driver population. Okay, because of driver population. All drivers are familiar, the factor is 1. Most of the drivers are familiar, more than 50% are familiar. Half and half, familiar, non-familiar, half and half. Mostly are unfamiliar. Okay, so more than 50% are unfamiliar. Okay, and then you have all unfamiliar drivers. Yes.
How do we know this?
Huh?
How do we know?
How do we know this? You have to do some surveys. It depends upon where the highway is and what type of demand you are expecting on the highway.
Can you look at the lane, the car, see the condition?
We can. If you have like the data, like if you can collect this data. Most of the cases we are just collecting the counts. Collecting the number plate data takes more time, right? So you need a camera or a sensor to do that. But if you can, just you can. Okay. Before I move on to the 4th factor, which will need some calculation, let me come back to this slide. Now, in the end, if I go here, how many speed adjustment factors you see? 1. How many capacity adjustment factors you see? 1, right? But how many conditions we discussed? 4. So there could be heavy rain and unfamiliar drivers. Heavy rain and unfamiliar drivers. So I will have how many adjustment factors? 2. I need to combine them, right? How do we combine them? You multiply. Okay? So if you have 2, you will multiply 2, it will become 1. If you have 3, you will multiply 3, it will become 1. If you have 4, you multiply 4, it will become 1. Okay, if you have multiple factors, you will multiply them. Got it? Okay, so the factor which you are multiplying in those equations is the product. Got it? Clear? Okay. Now the only factor which is left is the factor for work zone. Okay, what do we mean by work zone? Construction or maintenance activity. It is happening on the road or beside it. Okay, this needs some calculations. There is no table for that. Okay, so we will follow a sequence. The first thing which we need to calculate is capacity of the work zone. Okay, the first thing which we need to calculate is capacity of the work zone. How do we calculate the capacity of the work zone? You see the equation over there. In this equation, you see 2 parameters, QDR and alpha. QDR means Q discharge rate. QDR means Q discharge rate. When there is work zone, at what rate the vehicles are moving. Okay. And alpha is the reduction in capacity because of the work zone. Alpha is the reduction in capacity because of the work zone. Okay. It will be what? QDR means Q discharge rate. At what rate the vehicles are moving from the work zone? Maximum. Okay, and alpha is the reduction in capacity because of the work zone. Now for alpha, in the manual, they have given a value which is 13.4%. Okay, 13.4%. I look at the equation. You look at the equation. Okay, 13.4% means I'll put in the equation what? This is why I said look at the 13.4. Well, subtracting from 100, right? We are subtracting from 100. You cannot take 0.134 and subtract from 100. Got it? Yeah. We will see in the exam. Okay. Now the only thing is Q discharge rate. For Q discharge rate, we have this long equation. Okay. This equation needs a set of factors. Okay. What are the factors we need? We need the factor for lane closure severity index. FSCSI means lane closure severity index. Okay. For lane closure severity index, we have an equation. I didn't put it here, but there's an equation. There's an equation. Okay, I didn't put it here, but you can see it in the book. But they gave us the table as well. Okay. So, how many lanes we have normal without the work zone? How many lanes we have with the work zone? And you will get the factor from here. So normal lanes, work zone lanes, you get the factor from here. Clear? Now you see here 3 lanes, 3 lanes. Why do I have factor? 3 lanes normal, 3 lanes with the work zone. What's the problem then? The work zone is doing what? Nothing. It's next to the road. Okay? Maybe it's on the shoulder, maybe it's on the median. Okay? The number of lanes closed may still have an effect. Without the number of lanes closed, it may still have an effect. Okay. So FSCSI comes from here. Then we have factor for barrier type. Whenever we have work zone beside the road, it is safety requirements that you put a barrier between the work zone and the road itself. And the barrier is mainly divided into 2 types. You can have concrete or something else. Okay, concrete or something else. Something else can be anything. Okay, plastic, aluminum, steel, human being, whatever. You have seen that, right? With the flag. They do that. So, concrete FBR is 0, and for anything else, it's 1. Clear?
Is steel considered a soft?
Sorry?
Steel.
Steel is what?
Is a soft barrier?
Yeah. Steel is a soft barrier, obviously. Steel is soft, yes. Okay. Then we have factor for area type. Okay. So if the area is urban, the factor is 0. If the area is rural, the factor is 1. Then we have factor for day and night. Okay. If your analysis time, obviously if there is a work zone is for the whole day. Right? Work zone is for the whole day. You don't work for an hour. Okay. Work zone is for the whole day. But in which time you are doing the analysis? Okay. What is your peak hour? So my peak hour is night time. Okay. Then the factor will be 1. The peak hour is daytime, the factor will be 0. Got it? Okay. So this equation will give you QDR. Then alpha we know 13.4, or you calculate your own value. Okay, there are methods given in the book. But you will have the capacity for work zone. Using this equation, you will have the capacity of work zone. Okay. Now we are doing it to find out the adjustment factor. Adjustment factor is it given on the next slide? Yeah. Adjustment factor for the work zone will be capacity of the work zone from this equation divided by normal capacity. Okay, capacity of the work zone divided by normal capacity. This will give you adjustment factor of the work zone for capacity. Clear? Okay. Do we know how to calculate the normal capacity? We know how to calculate the normal capacity. Do we know it? Yes. Do we know how to calculate the normal capacity?
Speedboat density.
Huh?
Speedboat density.
Very good. Any other bright ideas? Yes. We don't know, right? So if this comes in the exam, you get 0. Right or wrong? So this will come in the exam. Or unless you think, wow, how do you calculate it? Okay. Then we have the free flow speed of the work zone. Okay, it's in the same slides, for God's sake. Like, what is your memory? Free flow speed, okay, the adjustment factor for free flow speed. So we need to calculate the free flow speed for the work zone. Free flow speed for the work zone, okay. Again, we have a long equation. This is called the speed ratio. FSR is the speed ratio. What is FSR? Given somewhere. Yeah. Speed limit normal upon speed limit of the work zone. So FSR is this ratio. Normal speed limit upon speed limit of the work zone. Clear? Now speed limit can be same as free flow speed. It can be less as well. Speed limit can be equal to free flow speed, or it can be less as well. Okay, you may have seen it in your data, the data which you collected on the highway. You may have seen it. Some drivers go over the speed limit, right? Okay, if it was a free flow speed, they would not be able to do it. They would not prefer to do it. All right? Okay. This is speed limit of the work zone, the value itself, not the ratio, the value. Okay. And then you have LCSI. What was that? Okay. FBR, factor for barrier type. FDN, factor for day and night. Okay, and the last thing which we will use later on as well, so pay attention, it's called TRD, total ramp density. TRD is for total ramp density. You know the meaning of ramp, right? Okay, ramp density means ramps per mile. Okay, ramp density is ramps per mile. You count the number of ramps you have and divide by the length. Okay, but in this case the length is fixed. This case the length is fixed. You always count 6 miles, so you divide by 6. The ramps are counted for a length of 6 miles. Okay, from your segment. The segment will be in the middle. So 6 miles means 3 miles this way, 3 miles the other way. Okay, then you count the number of ramps. Since you counted for 6 miles, so divide by 6. Got it? Make sense? Okay. Count the number of ramps for 6 miles. 3 miles forward, 3 miles back. Okay. Whatever number you get, divide by 6. That will be your TRD, total ramp density. Clear? Clear? If my segment is this one, okay. So from the middle, I will go 3 miles on this side, 3 miles on this side. I'll count how many ramps you have. Okay. The number divided by 6 because I counted for 6. This will be TRD. Okay. Now we cannot do this. Just go through the question. I will just try to explain the. We cannot do the calculations now, but I will try to explain the some important points from here. If you read, we are doing it for what? Adjustment for what? Oh, sorry, before that, once you find out the speed limit, the free flow speed of the work zone, the speed adjustment factor will be free flow speed of the work zone divided by normal free flow speed. Okay, free flow speed of the work zone divided by normal free flow speed. Okay, so the adjustment factor is basically the value of the work zone divided by normal value. If you are doing it for capacity with the work zone divided by normal value. If you are doing it for speed with the work zone divided by normal speed. Got it? Okay. Now, in this example, you see we have a freeway which is undergoing some maintenance work. Okay. The point which I want to make here, which is about all the adjustment factors, is it's a long-term work zone. So adjustment factors are not applied for temporary conditions, for short-term conditions. Okay. For example, weather. Okay. So we have, for example, heavy rain. That's it. Okay, and I'm doing it for bad. I will not apply that adjustment factor, because that factor will apply to maybe out of the whole year 1 hour. Okay, what are the chances of having heavy rain throughout the year, right? Nothing. But if I am doing it for a tropical country like Malaysia, Indonesia, they have more frequent rain, right? So there they will consider the factor for weather. Got it? Clear? Okay. Same thing for the work zone as well. The work zone is about like some maintenance work, new carpeting, which will be finished in 2 days. Fine. It's an exception. You just ignore it. But if it is a big project, okay, like a bridge construction, which will continue for 2 years maybe, okay, then you have to consider, because 2 years is a long period, it will impact the whole year, right? The construction will impact the whole year. Then you need to apply the adjustment. Clear? Okay. So we'll do this after the exam. So next time we will have the exam. Okay. Anybody who didn't do the